Okay. Thank you for inviting me, Christian, and for making time. It's a wonderful evening, isn't it? A beautiful day, and still you decided to come to listen to some American talk. So what I'm going to talk about this evening is implementing microservices, which I think in general interests most of you. And then the title of this is with DDD and actors, so with domain-driven design and actors. So specifically, I will drill down on how to implement microservices using domain-driven design with actors. My company is For Comprehension. Probably most of you know me because of this book, the red book, Implementing Domain-Driven Design. And actually I have this book also, Reactive Messaging Patterns with the Actor Model. So this is a sort of Scala and Akka book, but it talks in general about the actor model. What does the actor model gain you on a project or in an enterprise? And what are some uses of the actor model with domain-driven design? So that's this book. And then maybe actually you know about this book. It's Domain-Driven Design Distilled. It's actually been translated into German. And actually I met one of the translators last winter. His name is Hennig. Is that correct? Yeah. And I don't remember his last name, his family name. What is it? Schwentner. And is it Carolina or something, or? Carolina Lilienthal. Yeah, okay. So they they did the translation in German. This is a good thing. Actually, I want to tell you too about a little bit about my childhood. So my first Weltmeisterschaft, right? World Cup tournament that I remember is 1974, and I wanted Germany to win this World Cup, and they did, so you're welcome. But actually, so because I now learned about the various players, and actually I think at the time more than half the team, the World Cup team, was Bayern München, right, on that squad. And so I became very attached to this squad. It became my favorite football team, and so I think many of you would agree, except if you're from the north or something. But I am also a Bayern supporter. And even more, when I was about 12, I really wanted to tell Bayern what a big fan they had in the United States. So I called the operator in the United States and said, I want to place a call to the football club Bayern Munich, okay? And it took about, I don't remember exactly the time, but in those days, the operator would hang up from you, and then they would go through the process of making an international, over the ocean kind of call, and it would take about 15 minutes to 30 minutes to set up this call, and then the operator calls me back and says, here's the football club, Bayern Munich, and I spoke to some woman. I have no idea who she was, but I tried to convey to her that I was the biggest Bayern fan in the United States, and I think she must have been impressed. Maybe, I don't know. So, okay. All right, so here's a little, personal viewpoint that I have. I think really that we tend to be an industry of extremes. Software developers are kind of extreme thinkers. We buy into a technology or a way of doing things, And now this is the only way that we can develop software. And one of those things that I think happens is one of these sort of techniques that we get hooked on is ACID transactions. So our database has to support ACID. Not only our database, but if we're communicating across services, these services have to be coordinated through ACID. This is called, sometimes XA or distributed transactions or two-phase commit or, whatever you want to call it. And so it's ACID everywhere, right? Everything has to be ACID. Everything has to be certain. And I think what happens to maybe the reason for this is we're so used to synchronizing everything, right? We use objects, and with the objects, we have one object and another object, and we make a method invocation, and this method invocation guarantees that we block until the method returns. And there could be many things that happen under that method, and we're not only comfortable with the fact that the method blocks us or stops the object that has made the invocation, but we count on it. We absolutely rely on this. And so why not have our databases do the same thing? Why not, when I, make a service request to this service, and if some data in these other two services have some sort of consistency requirement, why not have all three of those services commit in the same global transaction, and everything is blocking, it's wonderful, and everything is certain, right? Everything in our life is certain. Ooh, now I can see you. I'm going to stay here. Ah, good, thank you. So, but how many things in life are certain?
Death and taxes.
What?
Death and taxes.
Death and taxes, yeah. Everything else in between is like, who knows? I could trip and fall on the way up the stairs tonight, who knows what, right? This could happen to anyone. And so, why should we be so certain about everything? Why ACID? Do you know what the businesses did before computers? I mean, maybe most of you are too young to know this, but I actually remember the days. My grandparents had their own little business where they made costumes. They made costumes for, robes and all kinds of interesting costumes. And the phone would ring, someone would be on the other end, they would order a costume. Right? My grandmother or my mother who worked with them would write down what the person wanted. Eventually they had an order sheet, right? Now, was the costume transactionally consistent? By the time I hang up the phone, the costume exists? Of course not. What exists? Some indication on a piece of paper that we have an order placed, right? Huh, interesting. An order has been placed. You know what? We place orders all the time. Attached to Amazon DE, we place an order. You know what? Order a book through Amazon. Yes, that's a good idea. Order my distilled book tonight on Amazon DE. But if you order the book, and all of you order the book on Amazon DE tonight, you know what's going to happen? 4 or 5 hours later, some of you are going to get an email that says, this item is out of stock. Right? Why did it take 4 or 5 hours? Why didn't they tell you right now? Right? I want to know immediately. I want my whole life to be certain. It's because that doesn't scale. It doesn't work. And there is no idea of certainty in this kind of order processing. Just like when my mother would take down an order about a costume on a piece of paper, it would go into sort of an inbox, right? a wooden inbox, not an email inbox. And my grandfather would pick this up, he would roll out some material, he would start schneidering, right? He would cut out the pattern, and now this would go to serging, it would go to different sewing machines, and then actually one of my summer jobs, it was called sore thumbing. Do you know what sore thumbing is? It's putting the drawstring into the tights, or what, you know, the slacks, and I had to put the drawstrings in, and it would make my thumbs sore, so my grandfather called it sore thumbing. And now, this process has been completed, but actually maybe it took a day or half a day, depending on the workload. Who knows? And maybe there was a rush, and maybe this person who wanted the costume would make a rush order, and maybe they would be willing to pay a little more to get a rush order. Okay. So that's the way business worked at that time. But you know what? Business really continues to work in the very same way at large scale. So why do we need ACID? Everything used to be eventually consistent, and we weren't afraid of it. My mother knows very little about computers. Well, she knows how to play solitaire on Windows and check her email, but programming? And yet, you know what? She was never afraid of the uncertainty of when a costume would be done in those days. And why should we be afraid of uncertainty today? Eventual consistency. Okay, there are some complexities to dealing with uncertainty because, yeah, messages may show up out of order, messages, you know, what do we do about all this? Well, there are answers to that, but, you know, essentially we have to deal with the fact that things happen eventually if we want our computer systems to scale, okay? Another extreme, size of service. What is a microservice anyway? What is a monolith? Should we develop with monoliths, or should we use microservices? Actually, sometimes a monolith is the right answer, right? I am not certain that microservices will do everybody ultimate good. But here's the thing, you have to be careful about the monolith because it can turn into this, the big ball of mud. And a big ball of mud is a monolith, but it's worse than a monolith. So it's where we probably have multiple domain models in a single, you know, sort of project area and deployable unit, but we actually can't tell where this domain model starts and where this domain model stops and where they integrate, and because everything is so convoluted and confused. There's so, you know, if you try to draw this on a diagram, you'll get dizzy from the number of boxes and the number of lines connected, and you make one little change over here and something over here breaks. You know what I hope some of you at least have experienced this. You know what I'm talking about. Not that I wish this upon you, but it's a fact. This is how software has been developed for a long time. Okay, so now let's say we're going to abandon the monolith. We're going to abandon the big ball of mud, and we want to transition into using microservices. What is a microservice anyway? What is the definition of microservice? This is one of the most complex topics, but do you know what these three numbers have in common? 100, 400, and 1,000? Any guesses?
Zero. They all have zero.
Ah, oh, boy, that's good. Okay. Yeah, that's true. But what do you think they have in common? No. We have, any other guesses?
They all could be the lines of codes for a microservice.
Very good. How many lines of code should a microservice be, right? And that's what, I mean, Christian, I love the guy. We think so much alike. He's so intelligent. Okay, so lines of code. Now, Christian said that he just had Fred George out to Auto Scout. Did Fred George say this?
The meetup.
Oh, he was here at the meetup. Okay. So did he say this here at the meetup, that one page of code is a good size for a microservice? Because if you look at this Vimeo video, he says this, and I actually don't, I've never met Fred George. I highly respect the man because he is the sort of microservices father, right? Is that true? So,
One of those fathers.
what is that?
One of those fathers. I believe Sam Newman is also in there and James Lewis.
Okay. And probably Martin Fowler had a lot to do with it, so.
No.
Yeah, so one page of code is a good size for a microservice. What does that mean? I don't know, I haven't asked Fred George, but here's the thing, okay? I have different definitions for page. One is, if I go way back to dot matrix printers, right? A page was about 62 to 66 lines, roughly, right? So should my microservice be 62 to 66 lines? Or does a page of code mean the amount of code that I can see in my IDE or editor at one time, right? Maybe. The problem with that definition is that as I get older, every year I change font size to a little bigger. So my microservices actually become much, much smaller every year. It's going to get, you know, by the time I'm like 60 years old, forget it. There'll be one line of code. Okay, so I don't know. I haven't spoken to Fred George about this, but with all due respect, I have to say, this scares me a little bit. So if I make my microservice 400 lines of code, is it a bad microservice? I mean, if, you know, I don't want to play games, but literally, if 400 lines is a good microservice, if I make my microservice 450 lines of code, does that mean it's a bad microservice?
Yeah. Yes.
Yes? Okay. Das tut man nicht. Right? Yeah, you thought I didn't know any German. Okay, so I actually don't know what this definition is, but I'm going to actually go more the Sam Newman route, okay? So maybe, I don't know if Sam Newman and Fred George agree or disagree, but I'm going a little bit different route. Okay, I give you a little hint. So how many microservices should there be? I think what Fred George is indicating is if you're using one page of code as a metric, it probably means that you have one entity in your microservice, and this entity is very, very, very narrow and focused, maybe just a couple of methods, right? And now we haven't even dealt with infrastructure and what are our message listeners or REST interfaces. I don't know how you can write a microservice in one page. But what happens is, if you follow the line of code count, let's say 100 lines or even 400 lines, it restricts the size of microservices to the point where now you've heard of class explosion, now there's microservice explosion, right? So we've gone from one extreme of a monolith saying, wow, we hate this monolith. There are 200 entity types in this monolith. And now we say, oh, a microservice should be 100 lines of code or even 400, and therefore every microservice should have just one entity in it. And now how many microservices do we have? 200 to solve the same problem. Tell me, can you reason about 200 highly concurrent and interacting things that are just happening all the time?
Fred George maybe can.
Maybe. But personally, I have trouble with that, okay? I'm telling you. You know, this is a cool story, I think, anyway. Have you heard of, Philip Wadler. Do you know who Philip Wadler is?
Yeah.
If you know Haskell, you know who Philip Wadler is. So he said, this I think is landmark. So I was at the same conference with him in Brazil about a couple months ago. And Philip Wadler said in his dissertation about how functional programming can actually be easy to understand, and monoids, they're easy, right? But you know what Philip said is, as in, I'm speaking sort of as him right now. He said, I make myself dumber every year so that I write simpler and simpler software every year. This is an extremely brilliant person, right? I mean, when you create the Haskell programming language, or at least have a share in it, and instruct people, and you know, he's a professor at Oxford, and how many other, I don't know, universities he's been a professor with, but this is a brilliant man, and yet he says, I choose to make myself dumber and dumber every year so that I create simpler and simpler software. Okay, I like that, actually. You know, so here's another thing that Fred George says. Again, with all due respect, this is the father of microservices. But he says in some enterprises, we have so many microservices running that we actually don't know which ones are relevant anymore and which ones aren't. So we just leave them running. And their reasoning on this, we're talking about wealthy companies, because he says the reasoning on this is it only costs about $400 a month to keep each of those microservices alive. Okay, brilliant minds, I guess, but I just can't deal with that. I mean, this is an uncertainty that I have trouble with, okay? So, it probably works for them, but give me a show of hands. If you have like maybe 1,000 microservices and 200 of them are no longer relevant, are you okay with that, and you leave them running? Show me hands. No? Nobody? Huh. Oh, so one person out of 200. Okay. So I think this sort of makes sense. Just for me personally. If it works for other people, perfectly fine. I'm not working on those projects. Maybe they're happy I'm not working on those projects. But the point is, you know, think of all the infrastructure that you need for those kinds of services. Think of all the complexity and how do you keep these things spun up? What if something fails, you know? I mean, we're not only talking about, if we have 1,000 microservices and 200 of them no longer are relevant, and each of those are backed by a cluster, that means we have probably 600 servers running that have no purpose whatsoever. Okay. So what is actually practical for a microservice? And of course, you knew it. I was going to give you a domain-driven design answer. What does domain-driven design say that could help with this situation? Oh, here's a tweet that I found that, let me see, what does it say? You are either building a learning organization or you'll be losing to someone who is. Did that surprise you? I just shifted from talking about the size of microservices to talking about building a learning organization. What does that have to do with microservices? Well, it has more to do with DDD. So if you are not learning through the use of a technique such as DDD, and I would argue that there aren't too many approaches to building software these days that any way rival domain-driven design, I don't think you're learning enough about the software that you're building. I don't think you're learning enough about the business. And so where will your business be in 2 years or 5 years if you're not learning to compete at the level that other organizations are competing because they know more than you? You need to know more than everybody else, and that is what DDD helps you do. DDD helps you to crunch knowledge, and as I like to say, you make complexity surrender to you. So make complexity surrender through domain-driven design. Learn from DDD. Collaborate. Build a ubiquitous language within a bounded context. Try one. See how it works for you. And this, I think, is extremely important. So what is a bounded context? This is one of the hallmarks of domain-driven design. A bounded context is a semantic boundary. So we draw a circle or an oval, and everything within that oval has a consistent, well-defined meaning, okay? As in, I have a concept in that boundary, and that concept is well understood by the entire team that works on it, both business individuals, business experts, and developers, okay? Sam Newman says, use bounded context as an indicator of the size that a microservice should be, okay? And I haven't met Sam Newman, and we've had a few Twitter exchanges on, you know, what do you mean by bounded context? Some people have asked Sam, how big should a bounded context be? And Sam has his answers, but, you know, if you ask how many here know anything at all about DDD? Most of you? Oh, wow, cool. So you already know about bounded context, but then somebody give me an indication. What size is a bounded context?
1 page.
Excellent. Excellent. In fact, yes, I can draw a bounded context on 1 page, right? Okay. Any other ideas?
Consistency. If you need consistency, then this is your bounded context.
Consistency of what?
With, well, within aggregates and...
Well, okay. Actually, aggregate consistency is a different idea than bounded context, but I know what you're saying. But what is the size of a bounded context? How long is a piece of string, right?
As long as you need it.
It's as long as you need. A bounded context is one entity type, maybe, but actually, it's the size of your ubiquitous language. So you have to ask your ubiquitous language, in essence, how big is our bounded context? And bounded contexts tend to be smallish because ubiquitous languages tend to be small. They're very focused on a specific kind of business problem that has a solution. This is interesting too. An interesting tweet. When we increase the size of a microservice, we increase the benefit of static typing for this microservice. Do you know what that means? Translate that for me.
Please do monolith.
No. No.
There's this in JavaScript.
It means that one entity type has no type. Think about that. Typing only makes sense when you have multiple types. A single type is no types. So if I have a microservice or hundreds of microservices that each have one type in them, there's no typing across all your microservices. So if you want to benefit from typing, put cohesive concepts together in the same microservice, a la the same ubiquitous language, okay? So linguistic components are cohesive. Linguistic components. That means that as the team that's working on learning, making their organization smarter, more intelligent, have more knowledge, the language that we produce is going to reflect a set of knowledge that we have built together as a team. And now we have a deep understanding of a particular problem space and its solution, and we're codifying that into a bounded context. And now we have a model that reflects the knowledge that we have gained together. This is extremely valuable. It not only reassures the business that we're listening to them, because they can actually see evidence that the model has produced what the business wants, but we've invested. We've invested in our people, we've invested in our own set of knowledge, we've grown our organization, and after all this investment that we've made, if someone decides to leave the company, we have exactly the knowledge that we need in the model to convey what was gained in past times. Is that not powerful? So this is what domain-driven design buys you. And linguistic components are therefore cohesive. So if we take a bounded context like this, and if you've read my red book, you know that I use Scrum as an example, because actually developers can sort of be domain experts in this. You know the domain of Scrum, and so it allows you to kind of understand this ubiquitous language quite extensively. But we have concepts in this model such as product, backlog item, release, sprint, team, team member, and product owner, okay? Kind of basic Scrum stuff. And so what we're actually achieving through this bounded context is a service, as in a subscription service, where multiple users can, actually multiple subscribers can subscribe to our service and use this model with a user interface to manage their Scrum/Agile projects for teams. But notice, how many entities do we have in this model? 7? Pretty small. Would you be ashamed of a microservice that had 7 entities in it?
How many branches does it have?
What? I mean, there actually might be more over time. Maybe a dozen. Does that concern us? Is it like, ooh, man, this microservice is too big? I think the best benefits of microservices is not actually scaling. I'm going to guess that if we really knew the scalability problems that you're facing, of any individual or teams represented in this crowd, I think that I don't think that you have Google scale problems, right? Maybe some of you saw my tweet a few weeks ago. I try to tell clients all the time, you're not Google, right? You don't need to scale like to Mars and back, right? Your scalability problems are probably not going to require you to split this up into 7 microservices so that you can scale products and backlog items separately, because we have just billions of these things in memory at any given time over a large cluster, and so we've got to like break all these up so they can scale. What do you think is the major benefit that you're going to get from microservices?
Conceptual clarity.
Okay, that's actually a good argument, but I think there is one that's even more practical.
Additional scalability.
Independent deployability.
So, rate of change. If the rate of change, so you have a monolith, and you have multiple domain models in the monolith, even if this is a very clearly modularized monolith that has each of the separate domain models in it cleanly separated, the rate of change across those models will probably be different. And so one team that is ready to deploy a set of changes will not be able to deploy because another team has made changes that were not yet ready to deploy. And so you've got this conflict of interest. And unless you can manage a monolith over multiple Git repositories, you've got this problem continually. So actually, I think that the rate of change is more of a measure of where you're going to receive benefit from microservices. Now let's just say that backlog item changes relatively often, and so does Sprint. Let's just say that those two change, but the others are relatively stable. It may be that you have to break backlog item and Sprint out of this deployment unit, right? Out of this single deployment unit, because you want to release changes to backlog item and releases of Sprint or changes to Sprint independently. But this probably has very little to do with scalability. It may, but perhaps not. And so I would suggest that you look at breaking up into smaller microservices more from the aspect of changeability than necessarily scalability. And yet, this microservice, if you will, or bounded context is small enough to reason about. So, which would you rather have? You know, a few bounded contexts, like 5, or if you count the individual entities, right, in here, it's actually about 35. So if you have one entity, as in typeless entity, per microservice, you have about 35 microservices, or you have 5 bounded context-sized microservices that are actually really quite small in the end. Personally, for me, I would rather deal with the 5 than 35. But again, each person, each team must make their decision. So a bounded context like this, or a microservice like this, is larger than one entity, but much smaller than a monolith. Much, much smaller, not even anywhere comparable. So the ubiquitous language is greater than the entity names. The ubiquitous language is entities, command messages, and event messages. What? Messages? Messages? Who's talking about messages? Oh, now we're coming back to everybody loves blocking, right? Blocking is our friend. Blocking allows everything to be certain. I call this method, or I invoke this method, everything is certain. I stop, the world stops for me to use this method. But not if you're using actors. Did you notice that I've drawn all my entities as circles instead of rectangles? That was a little hint, you know. I'm talking actually about actors, not the user interface actors, as in the roles that users play. I'm talking about actor model. So what I'm saying is, our actors serve as the entities. Product and backlog item are actors that we are able to send asynchronous messages to each of these. And the asynchronous messages go to a product or a backlog item or any other entity in our model, in our domain model, and what happens then? Internally, we do some sort of processing, and then we emit asynchronously an event about what happened. And do you know that there's not much more to a microservice of a bounded context than this? This is so simple. The architecture is so simple. You know, when we have to talk about hexagonal or, you know, onion architecture, ports and adapters architecture, we've got all these layers, and this handles transactions and security, and this layer handles this, and that layer handles that. Actually, with the actor model, you can get rid of a lot of those layers and the components associated with them, because this is pretty much it. You know what else there is? There are your controllers on this side, which could be REST you know, request handlers, endpoints, or UI controllers. And then over on this end, you have an event journal. And that's your whole architecture. Pretty simple, right? Do you know what you can do with domain-driven design to accelerate your learning, and with the actor model to accelerate your implementation when it's this simple? And it's not only simple, but it's both concurrent and parallel. So things are happening in parallel. We're using all the cores on our multi-core servers that, you know, okay, compare using the actor model to using Ruby on Rails with Ruby, right? Or using, I don't know, Python or something like that. So go look at your cores, monitor your cores while you're running one of those two systems based on those languages, and then compare that to Scala with Akka or another actor model implementation. And what you're going to see is practically on the actor model cores, you're going to see almost every core pegged constantly, which means you have 100% or close to 100% utilization of threads all the time. Whereas on the others, you're going to see one core pegged and the others sleeping. Pretty much. Maybe not always. If you really know how to you know, tweak those environments, maybe you can get a little better out of that, but not much. The other thing is each microservice should have its own database or databases. One of those is going to be your event journal that I just discussed. And so the actors, when they emit events, those events go into a journal. And once they're in the journal, they can be played out or published to other bounded contexts. And we'll get into that more in a moment. So they're consumable by others. And then you probably need a query model because, you know, your event, it's hard to get much out of the event journal other than, you know, reincarnating your command model. So the actors themselves are asynchronous services. Think of, you know, if we're developing microservices, and I hate to add another name to this, but maybe you think of the actors as, dare I say, nanoservices? Okay, I didn't say that. But they're very, very small computers, and each of these little computers know how to handle requests and responses asynchronously, and they get a lot of stuff done. So here's one of the reasons why, again, why we want to use actor model, because Moore's Law started to go away in 2003. You know, that's already 14 years ago. 14 years. And what have Intel and AMD and other companies done to address the fact that clock speeds are falling off or have fallen off the cliff? So every generation of Intel processor, we no longer get 100% performance gains. We get maybe 10%, okay? And so you wait 3 generations to get 30% gain. But because of the number of cores, we have a different solution. When Carl Hewitt, you know, basically discovered or invented the actor model, clock speeds were less than a megahertz, and transistors were about 7,000 to 8,000, 1973. You know, but today, can you imagine that someone 45 years ago envisioned that we would have processors to handle something that they were inventing 45 years ago? And I mean, it's just amazing. And Carl Hewitt knew that eventually we would have extremely fast networks, reliable, okay, networks aren't that reliable, but they're becoming more reliable within Google and infrastructures like that. So Carl Hewitt had a real vision. And of course, now that we have these multi-cores, all of us, you know, the software developers are going, dude, I'm going to write me some multi-threaded code, right? Because I am smart, and multi-threading is easy, right? So we go about writing this work queue, and here's what we do, right? Here's the big plan. The big plan is thread 1 is going to feed the queue. And while thread 1 is feeding the queue, thread 2, 3, and 4 are reading out of the queue and multitasking, right? Oh yeah? Thread 1 is blocked because thread 4 has to access. Thread 4 beats everybody else to the work queue, and thread 2 and 3 are now contending for the next task. Okay, let's say thread 2 wins. Thread 2 wins. We're going to get a work task from thread 2, and we're going to work on this entity. Oh, but you know what happened? The next work queue item that was enqueued, thread 3 gets it, but it's operating against the exact same entity. Who gets there first? We don't know. The scheduler for the processor is going to determine which thread actually gets there. It's either going to be 2 or 3, but either way, one of the two is going to block. And if they have 2 operations to perform, it's going to be, you know, in essence, a dance around who gets access to the entity. You know what we've actually done with this ingenious, you know, very smart programmer approach to multi-threading? We've turned a multi-threading processor into a single-threaded processor. That's what we've done, essentially, right? So this is what we're used to in OO, blocking, right? We love blocking. In the actor model, we have message sending, which is asynchronous. Everything happens asynchronously. So when this sender enqueues a message for this receiver, the sender keeps working. It just plows forward, and sometime in the future, maybe even right now, the receiver will process the message that was given to it in its mailbox. So, okay, that's one part of the actor model. What about creating reliable services? Don't put your brain on acid. That was the hidden message in all of this. Don't do acid. So we have a request coming in to this entity, and what do we want to do, programmers? We want everything in life to be certain and consistent. So when this entity is updated, somehow we make a request to another microservice and make sure that that entity is updated too, except we're not using a persistent store that that supports global transactions. And so what happens is actually right when this invocation happens, right? This service fails, or the network partitions, or that service fails. What I find is when teams do this, when software is designed this way, there are actually multiple developers that the company hires to patch data on a daily basis because these things break constantly. And so there's inconsistent data, right? In the very situation where we're trying to be certain about everything, we're causing uncertainty, but broken uncertainty, as in, we can't make this right. So that is something you really have to think about when designing these systems. So how do we solve this problem? Okay, Fred George, did he talk about this?
Yes.
So rivers, rapids, rivers, and ponds. As an overview, I'm just going to say that rapids are where everything goes. So if every microservice produces, like, you know, dozens of kinds of events, and maybe millions upon millions of instances of them, they all go onto the rapids. So if you're using RabbitMQ, you have one topic, or one exchange, I should say, where you send all of these events into one exchange. If you're using Kafka, just for example, you're putting all of these events onto a single topic. So the rapids is where messages, events are moving very rapidly, right? And from all kinds of microservices, at least all of them involved in your whole system solution, your problem space. Rivers. Rivers divert some of those messages, or frankly all of them, from the rapids into any given microservice. So the rivers channel the events to a microservice, and the ponds are the microservices where the data goes to rest, because ponds are sort of still, right? Rapids are flowing rapidly, rivers are flowing but not quite as rapidly, and then finally the data from those events goes to rest in a certain microservice, or at least has some impact on the microservice, which causes other data to go to rest. Now, I have to say that rapids, rivers, and ponds may not be the best way to implement microservices from a pure DDD perspective, but it makes the whole world a lot easier. Because now everybody sees every event, as in everybody in your whole problem space, you know, system solution, can see every event. From a DDD perspective, that may not be great, because essentially maybe it puts every every bounded context into a partnership, which maybe is not the best thing. But from the perspective of actually being able to add new microservices at any given time, a la bounded contexts, seeing every event can be very useful, and then filtering out the ones that you don't want. So this is, I think, very sound advice from Fred George. And so here's what happens. This bounded context or microservice emits an event, and that event goes into a single topic. This is the, right? This is the rapids. And then from the rapids, the event flows out through a river to another bounded context or microservice. And then potentially what a lot of domain-driven designs would do is they would take this event and translate it at the input port level to maybe a command or something that this language understands, because you have to acknowledge that the event from that other bounded context is a different language, right? So do you want everybody to speak, if you want to integrate with Spain, do you want everybody in Germany to have to speak Spanish? Or would you rather have a Spanish interpreter at your border that any message that you receive in Spanish gets translated to German, and now everybody just understands the intent in their own language? That's sort of what we're talking about. So when the event from this language hits the boundary of this language, we translate it into something that this language understands, okay? And then, because maybe this is a command that hits another entity here, entity actor, it's going to cause some state transition, and what happens? We emit an event, goes into our event journal, the water goes to rest, right? It's a pond now. Okay, but then what happens? Then that event that was emitted goes back into the topics. Everybody else can see it in your system solution. So this requires a high-performance bus. Could be REST-based, could be Kafka, could be RabbitMQ. You know what? This is the least important thing that you should be worried about. I have to say, man, so many people are just technology crazy, and they're just chasing, they got to put Kafka on their resume. I mean, what, seriously, I'm not saying anything against Kafka, okay? It's got its use, but why not just implement a simple REST interface that allows you to do atom feeds? That's actually all that Kafka is doing, right? Okay, it does it super fast, but do you need, 500,000 transactions per second? I don't know, maybe you do. Okay, so the rivers, you saw that, they channel over. Now notice that when we want an event to have an impact on another microservice, it's translated to a command. Because the command is linguistically accurate for this language, this bounded context, this ubiquitous language. And finally, the ponds are where the events, the data goes to rest, and then it starts all over again, right? The actors emit events to the rapids, and so forth. I think you get the idea. What I'm going to say here is that, it may surprise you that I'm going to say, you know what, this bounded context is too big. This microservice is too big. Too many lines of code. You know why? Because actually the language of offering resorts to certain vacationers is different from the reservation process of actually booking the reservations. Those are different languages. And so I'm not trying to indicate in any way that if you have one or two entities in your bounded context, that somehow that's too small. That isn't the point at all. Because actually, this is probably a better set of ubiquitous languages. One that understands making offers to frequent vacationers or frequent travelers. This one is, if they accept the special offer that you're making to them, then they book the reservation, and that's a different microservice or a different bounded context because the languages are different, okay? Actors are reactive. What does reactive mean? That means they're responsive, they're resilient, they're elastic, they're message-driven. And actually, message-driven is the sort of underlying characteristic or quality that enables the other three. Responsive. This is where, okay, if I test a given microservice or bounded context with a single REST request, I can very often see performance of sub 25 milliseconds, okay? Oh, that's great, but what if I suddenly get, millions of requests all at the same time? Responsive means that we can continue to respond at the same rate or relatively the same rate as we could under a completely different load. Resiliency or being resilient means that we are resilient to entire system crashes, which means that a single component that crashes cannot take down the entire system, or it shouldn't be able to anyway. So, is everyone here developing with either .NET or Java, let's say? Most of you? Yeah, almost everybody. So, tell me, you make a method invocation on an object. That method, there's something wrong with something, the state of that object or state of something else in the system or the parameters that you passed it, who knows what, and all of a sudden we get an exception from that object. What do you generally do with that exception? Be truthful. What? Log it. Okay. What else? Do you make that object recover from its crash? No way. You know why? You have no idea how. Right? What am I supposed to do with this? I log it and I rethrow, right? Let it bubble up. It hits the UI. What kind of message does the user get? Something went wrong, try again later, right? That's how much good we do for the users. In actor model, this is completely different because the client doesn't have to know anything about crashing components. The client makes a request to some sort of, receiver actor, and if the receiver crashes, the exception doesn't bubble back to the client and the client has to deal with that. What happens is this exception is reified into a message and the parent of the actor receives the message. Well, if you have a child, and I'm assuming that some here are parents, I am, what do you want? If your child has some problem, do you want to take care of it, or do you want someone you log it? Log. Man. You must be from Hamburg. Ah, you thought I didn't know anything about Germany. Okay. Actually, I learned that if you ask someone from Bayern, if they're from Bayern, it's actually an insult. Right? Do you know what I'm saying? That's what I was told anyway. I don't know if that's true, but yeah, so I'm not asking you. Okay, so we want to take care of our own child. We're the parent. We know what to do about this. We can shut down that child. We can shut down an entire... I'm talking about the actor. I'm talking about the actor. Man. Sheesh. Tough crowd. Noch ein Bier. Okay, so the parent can shut down that actor. It can shut down a hierarchy of actors. It can restart the actor fresh, or it can tell the actor to resume. There are a lot of options for it, but in essence, what we want to do is help the actor to recover in some way such that the client, you know what the client has to do? Here's what the client has to do. That actor crashes, it has no idea. But if it really, really cares about a response, if the response from that actor is important, urgent, critical, it sets a timer which causes a message to be sent after some period of time, and then that message, when it's delivered to the client will say, ask itself, have I seen a response from this actor? No? Then I'll resend the request. Hopefully by the time that request is sent a second time, the actor has already recovered and maybe even learned enough to know how not to allow that to happen again, that particular crash. So the client doesn't have to deal with crashes at all. The client only has to deal with, this is my request, did I get a response if I need it? Elastic means that we can grow and shrink the size of our cluster or any number of nodes as we need, as demand increases or decreases, okay? And message-driven, of course, is the actors are message-driven, the rapids are message-driven, the rivers are message-driven, the ponds are message-driven, it just keeps going in that circle. So, sometimes I show this Scala and Akka example. I'm tired tonight, and I'm not gonna, this is actually like not only my teaching, but I've given 3 talks in the last 4 days and taught a 3-hour workshop at another conference. And I'm sorry, but I can't do any more. But I'll answer some questions if they're nice. If they're not nice, I'm ignoring you. So what would you, do you have any questions?
I can just take up the mic to run up to whoever has questions. Oh, yeah.
What do you do in a highly available setting? When you have to be highly available and have multiple actors respond to maybe even the same messages?
Well, you have multiple actors responding to the same messages?
Because you want to be highly available and can't afford the
Okay, well, okay. In all good developer or software-based answers, you have to say it depends. But depending on the platform that you're using, actually like akka, you wouldn't have that situation because one actor instance is pinned into a node in a cluster. And if the request comes in on some other node, the request is rerouted to the node where that actor lives, and so that's what you get. And if that node crashes, the region that actor belonged to is balanced over to another node. Maybe another node comes up in its place or something, but it's the normal sort of clustering thing, except that, and this is important, one actor instance is in one place. So you never have to worry about concurrency violations in that sense, or even transactional conflicts, concurrency conflicts for transactions, because the actor is handling one message at a time, right? Perfect transactional boundary, and there's only that one actor anywhere in the actor system, which could be spread across many clusters or nodes in a cluster. Does that help? And I think even if you're using .NET and Orleans, it's a very similar answer. It's, wherever that actor lives, and if the in Orleans it's a little bit different in that it's a virtual actor, which means virtually the actor always exists, even if it never existed before. So if I send a message to an actor that either doesn't exist or has been evicted from memory, we load that actor somewhere in the cluster and route the message directly to it, but again, there's only one instance of that actor anywhere. Which actually, that is what an actor is really all about, right? If you have multiple, actors representing the same instance, I'm not sure that's really actor model. However, what platform are you running? .NET or?
Scala.
Oh, so are you aware of the Eventuate? Yeah. As in the Martin Crosser project? Yeah, so that's different. So Martin actually says you can bring up a single node in multiple data centers, right, representing the same thing, and then you have journal synchronization or replication across instances, and now if there are any conflicts between the multiple, instances of the same actor identity across all those areas, then there's a conflict resolution process that you go through, which can be either automatic, as in the software solves the resolution, or it may be have to thrown up to the user to sort out, right? Are you familiar with that?
Yeah, you would use CRDTs, for example, to automate that.
Okay, so I used Eventuate now maybe a few years ago, but I haven't seen the very latest updates, so maybe you're more aware of that. So.
And I can spoil 2 meetups. Eventually it was about Microservice Meetup number 15 around that. There should be a video available.
Okay.
Martin Russell was here. And audio is in a month's time, where we can listen to the .NET version of Actors. So
Oh, so you're going to get one of the Orleans guys, Sergey, or?
no, not one of the Orleans guys. This is one of the evangelists who used it, but
Okay.
we're talking about the actor model and service
Yeah, cool.
fabric
Okay.
in a month's time.
Yep.
So, spoiler alert over. More questions? Sure, yes.
So hi. So we are doing pretty much the same stuff, or at least the concepts are similar to what we do. We have a fairly large CORES system in production, and I would like to ask what's the relationship to CORES? Is it just a new style to implementing that, or a way to implementing that, or are there differences?
Yeah, no, okay, first of all, I hear people talk about a CQRS architecture.
It's a pattern.
It's a pattern. So within a single bounded context or microservice, you can use CQRS, right? And so what I would say is if each of these, maybe not all of these bounded contexts are using event sourcing, but if they are, then you pretty much need to use CQRS. But then CQRS would be implemented within this bounded context and separately in that bounded context, right? Does that answer your question?
Yeah, I was thinking because the central topic is basically, you could see it as like a kind of event store, right? Because you're globally collecting all the events and...
Yeah, well, that's what I was saying about, maybe I wasn't clear, but where were we? Yeah, so this is our event journal, right, for this particular bounded context microservice. So each microservice has, or each bounded context has its own database or databases. It could be that if you're using event sourcing, that you have a separate database for your event store, your event journal, and a separate database for your query model, right? So I'm not showing that here, but I did, right, somewhere along here, where did I do that? Yeah, so I did say you may have a query model in addition to your event journal, right? Yep.
Yes, and I totally agree that the Rapids is not the global event store for everything. This is
It's what? It's
the Rapids is not the global event store for everything. This is where you externally visible events are published to.
yes,
This
correct.
is important to differentiate.
Yes, yes. So when I say everything, I mean everything that you should put on there.
Yeah.
Right? Okay, one down front.
Oh, no, I'm curious.
So you said that you talked to Philipp Wadler?
I'm sorry,
I forgot this Lambda man, right? Lambda
Oh, Philip Wadler. Yeah, oh, yeah.
Exactly.
Yep.
And you said you talked about a lot of stuff. So I was just wondering, it's not related to the ARCA, but it's more related to the DDD. So how do you find DDD applicable to functional programming?
I think very applicable. I could be the chancellor, right? I could take place for Merkel, yeah.
It's like log it and then shut it down.
Yeah, so here's what I'll say is I use Scala. From my perspective, I'm not a very good functional programmer. If you're a Haskell programmer, you would probably find fault with the code that I write. But if you're a Java programmer, you might be impressed. So
I actually have something. I have a feeling like that. So
yeah, so I'm sort of like an FP light kind of person, and I say, how can I explain monads when I can't even ski them well? Yeah. Okay. Nobody got that. Mogul, monad, mogul, monad. You're not skiers? You live in Bayern and you don't go to Austria to ski?
We don't have moguls.
Okay, you don't have moguls. Anyway, yeah, so I think it's very applicable, but here's the thing, right? I mean, the way I view it, I don't program in Haskell. I've read a book about Haskell. Haskell's a little unfamiliar to me, as in the syntax, but the further I read in the book, the better I liked it. But I've never even written a line of code in Haskell. But I've written a fair amount of Scala. I feel comfortable with Scala. And I think that from a functional approach, okay, so in Scala, we have case classes, and we have the ability to import sections of objects. And so if we have an object that has some functions in it, actually methods that don't mutate the state of anything but take a parameter and output. So you can imagine having a backlog item record, or, you know, okay, in Scala it's an object. In Haskell it would be a type class, right? And a type class with, I can't remember an instance, but maybe it's called a record in Haskell, I can't remember. But so you get this piece of data back, and you hand this data to a function. The function doesn't mutate that data. In fact, it can't, because the rules of the language or whatever, you know, component type that you're using doesn't allow you to, so it must return some kind of value. It could return either a value of the same type, or it could return an event that says, now this event will be persisted, and the state of my, you know, my record will now be reconstituted from my previous events, including the most recent event that we just persisted, and in essence, the event stream, the state of your record is the left fold of your event stream, right? And that's just sort of like a very quick synopsis of how you would use functional with DDD, but obviously the function should do something according, you know, adhering to the ubiquitous language. But a lot of functional programmers only like to think in terms of data and mapping and folds, and so it's sometimes hard to convince functional programmers that we even need type classes, right?
yeah, okay.
You know what I'm saying?
It's just a tooling, yeah.
It's just endless debates over how this should be done. So,
Okay.
but I have my viewpoint. I don't know if that was helpful.
There are some very good presentations on this topic I've seen, but not with Scala, but with F#. So there are great talks about F# and domain-driven design, and how actually the type system helps you very much with modeling your aggregates. Further questions? Yeah, first row.
I'll ask a simpler question. So I'm pretty convinced, and you're pretty convinced that not doing threading and
That what?
that not programming in threads, and rather modeling and programming with actors is the way to go, and DDD is a nice match for that, and maybe even functional programming is a nice match. You know, think of Erlang or Elixir. This change of state is just a function of some input that you know that you get. But have you convinced hardcore thread programmers to reconsider their religious views and, you know, change?
I don't
What's
know.
your experience? Or
I haven't worked on a project with someone like that, but in all the times where I say that, you know, like Brian Getz will say, most multi-threaded programs are wrong. And I was recently at a conference and I asked a large audience, or I said to the audience, most multi-threaded applications are wrong. Is there anyone here who feels that they have a multi-threaded program that is absolutely correct? And one guy raised his hand out of hundreds. So, you know, I don't know. But here's the thing, okay? Actually, sometimes multi-threading is easy. I've implemented really multi-threaded programs in Java. You know where it breaks down is when someone wants to change something. So you come up with this concept, it's beautiful, the threading works perfectly, and now there's a change of requirement. I don't mean just like a little change, I mean like cuts across and you go, what? Why? You know, this is so beautiful. Right? But you have to do it, and that's when you start running into threading problems. I mean, try to refactor that, right? Poof.
But if you use immutable objects, then I think you're in a safe line.
I think it was highly immutable, but not every piece was immutable, but it was highly immutable. But no, the requirements completely changed to, I mean, in one case that I'm thinking about, it was entirely automated, right? Entirely automated, just a computer, in this case, talking to a machine, and the machine would feed it data, and then all of a sudden the requirement came up, allow the user to intervene in some cases right anytime they want to. You know what that does to like multi-threading? I mean, it's very difficult to allow that, you know, it just rippled everywhere, and it was horrible. And not only that, but ultimately you're always under the time crunch, right? It's not just change everything, it's change everything in 2 days. Right? So
just one comment. Maybe you can think of the actor model as the grand unified architectural theory, because you just have you know, events coming in and
I'm sorry,
commands coming in and events coming out. So it's the simplest architecture that you can just replicate.
Right?
It's
so simple.
Yeah.
The only thing that I would caution on is be certain that you need to use event sourcing, because event sourcing is super simple as long as nothing changes. As soon as you merge, you know, two aggregates or two entities into one entity type, or you split one entity into 2 or 3, or you get trillions of events build up in your store. I mean, do you actually have storage capability to hold all of those events over time? I'm not saying that you don't or can't, but it actually takes a special design of an event store to deal with that. So, yeah.
What kind of an event store are you typically using then?
Oh, well, it depends, but one based on, yeah, more recently I've been using one based on Cassandra. So.
Okay. The akka persistence one.
What's that?
Akka persistence with Cassandra?
Yeah, and also eventuate with Cassandra. Okay. Yep. But here's the thing. Okay, I don't stick around for years in projects anymore, right? I get to see the good parts. You know what I'm saying? So after a couple of weeks or months, I get to see all the good stuff happen. It's after that you have to watch out for. So just be advised, right? And if you're a consultant, you know what I mean.
Final question, okay?
When you talk about actor recovery, so what do you think about the way we solve this recovery problem is a publish-subscribe model and a queue. So a
recovery of what?
So you mentioned about the recovery of the events. So when the actor fails.
Okay.
And you mentioned that basically a parent actor is retrying message until it succeeds, right?
So the parent actor receives a message that indicates the exception that occurred.
Yeah.
And now the parent can make a decision based on the exception that occurred and tell the child to restart or ignore or whatever, right? Okay?
So the way how we solve this is a publish subscriber model, and also one of the subscribers is a queue, and the client has to read from the queue to acknowledge that basically
So the parent publishes an event that says the child crashed?
No, so
You're telling me how you do this?
No. We just,
Or you're asking me?
I'm asking about
okay.
this, how we did it. Is it okay?
Oh, I see. Okay.
So basically, how we solve it is that we have a publish subscriber model, and all our clients are basically subscribers, and each of them has own queue, which is also subscribed to the same subscriber. And when client receives an event, also has to clean the event from the queue in order to basically, it's a fallback if app is crashed, for example. Then when it, for example, the server starts again, it will read from the queue and it will clean up this event. And on top of it, we have a versioning, which is if it's already a new event, which is acknowledged to the subscriber, actually to client. If the version of the event is old, it will just ignore it.
Okay, so what I would say is it's impossible for me to fully understand what you just said without, maybe having some more conversation diagrams, but it sounds to me like you have possibly some domain events that you're publishing, but you also have some infrastructural events that are helping the system recover from problems. And the events that clients are seeing, when you say client, I'm not even sure what client means. When I'm talking about client, I'm talking about another actor, just a very small thing, right? You're probably talking about a client like a remote client, right? Yeah. Yeah. So in that case, I think what you're saying is you have some sort of infrastructural event that goes out to tell client-bounded or microservices something went wrong here. You may want to be aware of this.
So the way how it recovers, that it knows that it should pick this event because the event when it's broadcast, and if the application is down, when it starts up again, it will read it from the queue, which is basically SQS. And if the event version is the same with basically, because we store everything in Elasticsearch when we need to aggregate the data.
Maybe just
why don't we take this offline?
Yes.
Yeah,
so
this is
I
a
believe
good,
this is not of general interest. So, thank you very much for being here. Thank you very much, Vaughn, for taking the time out of your busy schedule to be at this meetup.